Okay, let's get started. Remember? Let's get started. Here we go. Okay, we're going to start. Here we go. So I just wanted to draw your attention to, in the office hours section, Jerem is updated when he's there. So he's got slightly different hours in the help room. So you can check that out. That's right there on office hours on the left side of Blackboard. Okay, so my office hours. I have normal office hours in ECA in my office, and then I do spend an hour there, 10 to 11 on Tuesday mornings. His hours are different, but just don't forget about the help room. Okay, that's going to be your best bet for help outside of us two, and then you can find us there also. Okay, any questions on that? So it's like open all business hours all week long, closes Friday at 1. Okay, but Monday through Thursday, it's like open all day long. Okay, take advantage of that. So I want you to work, while I take attendance, number 7 on page 164. Just read the setup, okay? Just read the setup. After you read the setup, then we just want to fill in these tables, okay? So don't answer the questions there asking, just get the setup, read the setup, and then fill in the tables I've got on the screen. Okay, so again, just read the first paragraph. Don't read their questions A, B, C, D. Just read that paragraph, and then you're gonna, after you get the setup, then you're gonna fill in these tables. And then it talks about for the first 5 years. Just ignore that. Just assume that that's like indefinite. Okay, so just ignore where it says the first 5 years. So suppose it's the first 20 years. Okay, and you're gonna fill in exactly what I'm showing here on the table after you read that paragraph, and you can work together. Okay. Okay, so what was the scheme for Company A? How did the salary increase? By 5%. So we could start by finding 5% of 66,000 to figure out how much the raise would be. How do you do that? How do you find 5% of 66,000? Was that? No, just the raise. So yeah, you're ahead of me. Is that 5% of 66,000? Is that 5% of 66,000? Listen to my question.
Yes.
Is that 5% of 66,000? Yes, that's how you find it. You take 0.05 times 66. You take that portion, 0.05 of 66,000. Is that the salary the next year? No, that's just the amount of the raise, right? You'd move to another company if they did that, right? So to get the salary the next year, we want to add 66,000. Okay, which is equivalent to if I could factor out the 66,000, and I'd have 1 plus so this is the same as 66,000 times so that is equal to taking 66,000 and adding it to 5% of 66,000. Multiplying by 1.05 is an equivalent calculation to finding 5% and adding it to the previous salary. So looking at this number right here, what does the 1 represent in this number? What does the 1 stand for, represent?
The salary of that year.
The salary of that year. Nicholas? But what does the 1 mean? What does the 1 mean? So that's because it's greater than 1. But what's the 1? Yeah, so it's like you get to keep the salary you had before, right? So the 1 is like the 66,000 you had the previous year, and the 0.05 then that's the amount of increase, right? We saw that right here. So 1 is like you have the salary you had before plus the amount of increase. So that's how that multiplying by that number achieves that result. So what is this? So what did we get for that? Did you get 69,300? And we can achieve that by taking 66,000 and multiplying by 1.05. What about the next year? How can we find the salary the next year? Okay, so can you just do the same thing again? Do you have the 69,300 plus 5% of that? So it would end up being the same thing. And so, in effect, we could just take this new salary to get next year's salary and multiply by 1.05. So is the amount of increase staying the same? How much the salary goes up in dollars, does that stay the same? What does that do? Does that increase or decrease? It increases because you keep taking 5% of a bigger and bigger number, right? So the number of dollars that your money goes up increases. But what's staying the same every year? And what? Yeah. Okay, the growth factor is staying the same, but what else is staying the same? It's not the amount of dollars that it goes up by, but percent that it goes up by. So multiplying by the same number, multiplying the previous output by the next output, means a constant increase in... No, not a constant increase in Y. We said the dollars that's going up is increasing, right? So, but what is the same? The percent increase is the same. The percent increase is the same. When you multiply by the same number over and over again, that's the given. You multiply by the same number. What you get is a consistent percent increase, but not a consistent number of whatever the units are. In this case, dollars. Okay, so we could keep going like this, and for 3 you should have gotten... So how can we think about how to find the salary after 16 years in this same scheme? So this number right here. We don't want to, so what would we do? We would keep multiplying by 1.05 until we got to the 16th year, but we want a shorter way. We'd think through that. Yeah, Margarita.
16, 1.05, so that's like 1.05 to the...
Yeah, after 16 years, how many times will we have multiplied by 1.05? 16 times, once a year for 16 years. So, and what are we going to multiply by 16 1.05s? 66,000. So it's this initial amount, 66,000, By the time we get to the 16th year, we will have multiplied by 1.05 16 times. What is exponential growth about? What operation? Multiplication. Repeated multiplication by the growth factor. This is the essence. This is the bottom line. You got to remember that. Okay? It's not about memorizing formulas and plugging numbers in. It's about repeated multiplication by the same number over and over. Multiplication on what to get what? Multiplication on what to get what?
The output to get the new output.
He said the output to get the new output. Ashley likes it. Right. It's multiplication on the output to get the next output. That's what the growth factor is. Okay?
This is the growth factor, the initial value, or the exponent?
Now, the growth factor is the multiplier. The growth factor is the multiplier. Initial value is 66,000. So what is the growth factor here, Eric? 1.05. It's the thing you keep multiplying by over and over. This is kind of the centerpiece of exponential growth, is this number that doesn't change that you keep multiplying by over and over. And when you have that, you have consistent what? What kind of change do you have? Percent change. When you multiply by the same number over and over, you get consistent percent change. So those are kind of like two ways of looking at exponential growth. Consistent percent change or repeated multiplication by the growth factor. They're one and the same. So you should have gotten 144,000. Year 16. Okay? So then looking at the nth year is like writing the function. It's like writing the function f of. So after n years, how would you get the salary? You'd start with the initial salary and multiply it by, instead of to the n, how else can we say it? Multiply it by 1.05 n times. When you see 1.05 to the n, you read it 1.05 to the n, but you think, what do you think? A bunch of 1.05s multiplied together, n of them. N of them. In the case of 16, 16 of them. Okay, so this is exponential growth. Two ways to look at it. Repeated multiplication by the growth factor on output. The other way to think of it is consistent what? Percent change. So notice, when you have a growth factor of 1.05, look at that number, 1.05. What's your percent change? Remember we said we were breaking down this number. The 1 is what you had before. So here's the change. Here's the change, 0.05. All right, so 5% increase. So a growth factor of 1.05 is synonymous with, means the same thing as 5% increase. Okay, over here, much easier. How does this one go up every year? What operation is that? Addition. How much is the input changing each time? The input. How much does the input change each time? 1. So look, we have equal changes in input. In this case, 1. And what do we get? We're getting the same change in output. We get equal changes in input. We're getting the same change in dollars in output. That should sound familiar. What's that? Equal changes in input result in consistent changes in output. That was one of our perspectives on constant rate of change. Constant rate of change is repeated what? If exponential growth was repeated multiplication, constant rate of change is repeated addition, right? It's repeated addition. On what to get what? Repeated addition on what to get what? On the input to get the output. On the input to get the input. What is it? Repeated addition? On the output to get the new output. Still, right? We're taking this old salary, adding 1,500 every time to get the new salary. It's still a repeated addition on output to get the next output. Delta y's, right? Delta y, delta y, delta y. Stays the same. Okay, so we want to bring these, when you're solving problems, when you're doing homework and web work and you're solving problems, you want to bring these principles to the table. You don't want to just look for methods and formulas and procedures, okay? This is what's going to empower you to solve any problem, not just the one that you memorized the rules for, okay? So that's why we're really emphasizing what's going on behind the scenes. If you know that really well, then you have much more versatility and much more ability to solve problems than if you just memorize rules and procedures. Okay? So when we're talking about this stuff, don't tune out and just wait for the punchline, which is going to be like, where do you plug in what, where? No, take the opposite view. Take the opposite view. Okay, let's try some more here. So go over to page, the same page, just 165. Number 9. So it talks about a bacteria in a Petri dish, and it's decreasing by 12%, and the initial mass was 203 micrograms. Okay, same thing. Let's just ignore their questions and make my table here. So just you work on my table. But the initial amount was 203. It's going to decrease, the mass is going to decrease 12% each hour. Figure out and make the table. Go. So lots of you are making good progress. I want to start again one more time. I want to do it the long way. So I want to start by finding 12% of 203. How do I find 12% of 203? .012 times. Okay, so is that 12% of 203? Is that 12% of 203? Is that how much bacteria is in the dish 1 hour later? No, what is that number? How much it went down, right? So to get the new amount, I'm going to start with what I had before and do what? So it's the same thing. You start with like your baseline is what you had before. And then with the salary, what? We added a percent. We added 0.05 of the previous salary. Now this is decreasing, so we're going to start with the previous amount. Now we're going to subtract a percent of the previous amount. In this case, 12% of 203. So if I do the math here, factor out 203, I get 1 minus 0.12, which equals 0.88. So actually, this is decay because the amount is going down. This is a little trickier than increase, because when I look at this 0.88, I can't just point at the 1 and say that's what I had before, and then the other stuff is the amount of increase. Now I have this number 0.88. I'd have to come back to this step and say, oh, here's my amount from before, the 1, and then here's how much is going down. So when you look at this, then this number, well, let's do it. So to get this next number, it can just be 203 times 0.88. That has the effect of taking 203 and subtracting 12% of it. So now my multiplier is what? 0.88. Can I do that again to get the bacteria in the next hour? Does it work? I'm going to start with 178 now. I'm going to subtract 12% of 178. Is that the same thing as multiplying by 0.88? Yeah. So every hour, a 12% decrease means multiplying by 0.88. Does that make sense? So here's the numbers you should have gotten, at least for those two. Okay, so after 25 hours, how much will we have? Brandon, did you get this? Yeah, I want to know the mass after 24 hours. How would I set up for that? 203 to the 25th power. And what does that mean, 0.88 to the 25th power? Just what does it mean?
It means 25 is 8.
But 0.88 to the 25, what is that representing? What does it mean to do? How does it relate to the way that the bacteria is decreasing?
It's like, I don't know.
Okay, cool. Chad? Nice and loud? Right, so it's taking 203 and multiplying it by 0.8 25 times. Why do we multiply it by 0.88 25 times? Yeah, because every hour we multiply by 0.88 for 25 hours. That would result in 25.88 multiplied together. This is what you want to practice when you're working problems. Practice this thinking. Okay, practice this thinking because it can help you solve all kinds of problems when it comes to exponential growth, because this is the very nature of it. This is the very essence of it. Okay, so what about after H hours then? Christopher, go ahead. To the and tell me what that means. 203 times 0.88 to the H. What does it mean? H hours after. So you would take 203 and you'd multiply by times H? H times. You imagine 0.88 H times in a row. List it out, multiply it. H 0.88. H 0.88 multiplied by 203. Okay, so is 0.88, is that the amount of decrease? So this is what we call our decay factor because it's getting smaller. So this is 0.88 is the decay factor. How can we think about that number, a decay factor? What is the 0.88? What does that mean? Danny.
That's the total you have after it decreases, basically.
So it's what you still have. It's what you still have. Is that right? The 0.88. Yes? The 0.88. What does that mean? What does that number mean? He's saying it's the amount you still have.
Yeah.
Matt, you agree?
Decrease.
He's saying it's the amount of decrease. 0.88 is the amount of decrease. Some nods to that. Well, it can't be both, right? What is it? Is it Sean? The percent decay. So the percent of decrease. We got some conflicting reports here. Jed.
The amount available after
The amount still around after the decrease. Sebastian likes that. Walter. The percent change. We keep going back and forth. It's one or the other. Is it the percent change? Is the percent of decrease? Or is it the percent that remains after the decrease? Okay. How much is it decreasing by? 12%. So the 0.88 is the other 8 point. It's what remains. Or what you keep. This is important. A decay factor, because you've got these two different things. You've got the amount of decrease and the amount that you save. So with 12% decrease, what remains is 88% from before. And that's what you see in the decay factor. When you look at the decay factor, you're looking at the portion that you keep. So with these growth and decay factors, they're always based off of this baseline of what you had before, 1. If it's growth, then what do we do with the percent? We add a percent. If it's decay, we subtract. So we can think of that, this is the percent, we can think of this as the percent change. And when R is negative, we have decay, because it would be 1 minus the amount of decrease. So you always start with this baseline of 1. And then if you have percent increase, then you add a certain, like we had before with salaries, 1.05. Remember that was 5% increase. If it's decrease, then that R will be negative, and there'll be 1 minus the amount of decrease. So you always have that baseline 1, and then you're either going to go up from there. That's a growth factor then. You get a growth factor. Or you're going to go down from 1. And that's going to be a decay factor like this, 0.88. Okay, so let's practice determining, I'm going to give you a bunch of growth and decay factors, and you're going to tell me what so for all those right there, determine the associated percent change for each of these. So this is the multiplier. This is what you multiply output by to get the next output. In each case, what is the percent change? Either the percent increase or the percent decrease. Okay, give it a shot. See how you do. So each of these numbers is a number like this, 1 plus r. Each of these numbers is a number like this, 1 plus r. And you're figuring out what r is as a percent. Yeah, sure. No, not quite. We'll actually do that in the next couple of days. That's called the 2-year growth factor. But it wouldn't be 2 plus r. It'd be different than that. But we'll do that. We're going to do that. Okay, figure these out. This is important. Given the growth or decay factor, what's the percent change? Did everyone get their homework? Who's here? Anybody not get their homework? Okay, no, you don't have them all done. Maybe some of you do.
So if it's 0.84, what's the 0.84? Is that the percent change? The 0.88 was that the percent change? So that's how much you keep. So you need to figure out what 0.84. You need to figure out what is the. Okay. No, that is the percentage kept. You want the percent change.
Okay, how about Devin back there? 1.72, what's the percent change? Nice and loud. The first one, 1.72, what's the percent change? The first one that you're working on a list here, up there to the right, the first one's 1.72, you're supposed to find the percent change. Did you find that? Okay, what are you doing back there? Margarita. 72%. And how'd you get that? Or why is that? Why is it that? When you look at the 1.72, you'll see the 1. What's the 1 mean? What it had, yeah, it kept what it had, and then you looked at 0.72 is how much it went up, right? So you have the 1 from before plus 0.72 is how much it went up. All right, 0.84. Kayla, did you get it? What'd you get? Decrease of 16%. So if we write it as a percent change, so there's two ways to express this. As percent change, it's negative. But it could just say 16% decrease as a positive value, but then indicate that it's decreased. Those are both equivalent ways of saying the same thing. So you got to watch out for that, because like a problem will be given, it'll say a positive decrease. As a percent change, that's a negative number. Does it make sense? Okay, 0.08. Somebody new. Let's see. How about Miley? Is it Miley? Riley? No, Miley. What is 0.08? What percent change is that? Nice and loud. Ramey. It's not Ramey, sorry. Negative what? 0.92%? And how did you get that? Right, so if 0.08, so how much is kept? If it's 0.08 is your decay factor, what are you keeping each time? You're keeping 8%. That's what that tells you. That you're going to hold on to 8% as you move to the next output. If you're holding on to 8%, then you must be decreasing 92%. Okay, 1.08. Maria, what's the percent change? Plus 8%? Okay, 1.95. Sarah? Plus 95%. Okay, so 2. If the growth factor is 2, what's the percent increase? Yeah?
100%.
He wants 100%. All right, so this is where it gets a little tricky. It's very easy to think it's 200%. But why is it 100%? Because 2 is really an additional 1. It's 1 plus 1. So the 1 is what you had before. The increase then is 1. So you still have to think of it this way. Look at that 2 as thinking of it as 1 plus something, and that something, in this case, is 1 or 100%. So therefore, 4.5. Yeah, tell me. 350%. What does everybody put on the test, or think it's on the test? 450%. It's not 450% increase because you have the 1 from before. The amount of increase would be 3.5. So don't, on the test, don't put 450% like 3/4 or 4/5 of the students do. Okay, you've been warned. Okay, here we go. 0.99% change. Negative 1% is the percent change for that. You're keeping 99%, so you're going down 1%. Okay, so in these questions, you're going to have lots of these situations. They will often, okay, I'm going to change subjects here. Any questions about finding percent change from growth or decay factors? That's really key. Any questions on those? Yeah?
What if it says like it decreases in negative percentage? Is that like possible?
Yeah, it just wouldn't be well stated. So if it's decreasing and negative, then you're increasing. So you would never say that. You know what I mean? Like,
I just made sure.
yeah. So that would just be poorly stated. Okay. So in lots of these situations, what they'll often ask you is, you know, given an amount. So let's say we want to know, when does the bacteria mass reach, say, 50? Okay, so when does the mass reach 50 micrograms? So what we're saying is, we know that this amount is 50, and we need to know how many times we multiply by 0.88. Or we need to know what the exponent is. So for now, you're going to solve that graphically. I'll show you here in a second. But whenever you're trying to find the input, which is the exponent, you're going to solve it graphically. So you're on your graphing calculator. So what was our function? 203 times 0.88 to the, in this case, I'm using x for the input. Okay, so this is our function for, what's the input and what's the output of this function? What the input stands for, what quantity? X is just the variable. What's the quantity? Number of hours since the first observation. Output is the mass of the bacteria after that many hours. So I'm going to graph this. Why can't I see any? This happens on your graphing calculator too, right? You graph something, you can't see anything. What's going on? What's the initial amount? 203. I'm only showing 1 to 7 here, 0 to 7. So I need to zoom out on my y-axis. Okay? And I only want to show this for a positive number of hours. Okay, so here's the graph. So how can we find out how many hours it will take to reach 50? We want to find out how many hours it will take to reach 50 micrograms. This is a common question you'll have. So I'm showing you how to approach it. Use a graphical approach. So how would I do that? Okay. Right. So what you can do is you can actually, he's saying we want the y value to be 50, so you can graph another graph and use a line at y equals 50, and you're trying to figure out at what number of hours so you can use your graphing calculator to find the intersection of that output y value that you want, and then that x value then will be the number of hours to get that output, in this case 50. Looks like 10.96. This ordered pair is 10.96 and 50. So how many hours does it take to reach 50? When we got to the 11th hour, then we'd know for sure we had at least 50. Okay. Remember what a point on a graph represents. It represents two values taken together. Two values. In this case, a number of hours, input, and the corresponding mass at that time, output. Every point on a graph gives you two values taken together. Okay, web work for Monday. And then the quiz, if you read on Blackboard, we do have a quiz. It's past stuff. It counts. Do your best. Counts toward your grade. Remember what we've talked about.